Something unusual has been happening in the Sahara Desert. In regions that were once completely dry, scientists are now detecting signs of water. Satellite images show patches of vegetation spreading across areas that used to be bare sand. In some places, seasonal lakes are forming after rainfall. And in certain regions, underground water is even beginning to reappear closer to the surface. This raises a surprising question. Is the Sahara Desert starting to turn green again? At first, that idea sounds unlikely. The Sahara is the largest hot desert on Earth, covering about 9 million square kilometers, roughly the size of the United States. It stretches across North Africa and includes some of the driest places on the planet. In many areas, rainfall is less than 25 millimeters per year, and some regions can go years without a single significant rain event. But despite these extreme conditions, the Sahara has not always been a desert. Thousands of years ago, much of this region looked completely different. During a period known as the African Humid Period, which lasted roughly from 11,000 to 5,000 years ago, the Sahara was covered with grasslands, rivers, and large lakes. Fossil evidence shows that animals like hippos, crocodiles, and even early human populations lived in areas that are now completely dry. So what changed? The main driver is Earth's orbital cycles. Small variations in the tilt and wobble of the planet affect how sunlight is distributed across different regions. Around 5,000 years ago, these shifts weakened the African monsoon system, reducing rainfall across North Africa. Over time, vegetation died off, soils dried out, and the Sahara transitioned into the desert we know today. But the climate system that created the Sahara is not fixed. And in recent decades, scientists have started to observe signs of change. Satellite data collected over the past 30 to 40 years shows that parts of the Sahara, especially along its southern edge in the Sahel region, have experienced increased rainfall. Some areas have seen precipitation rise by 10 to 30% compared to the severe drought periods of the 1970s and 1980s. This increase in rainfall has had visible effects. Vegetation has expanded across parts of the Sahel, with grasses and shrubs returning to areas that were previously barren. Researchers using satellite imagery have tracked a measurable greening trend across large portions of North Africa. In some cases, temporary lakes have formed in low-lying desert basins after heavy rains. These lakes may only last for weeks or months, but they indicate that water is becoming more available in regions that were once extremely dry. Another important factor is groundwater. Beneath the Sahara lies one of the largest underground water reserves in the world, known as the Nubian Sandstone Aquifer System. This aquifer contains vast amounts of fossil water that accumulated thousands of years ago when the region was much wetter. In certain areas, changes in rainfall and surface conditions may allow some of this groundwater to move closer to the surface. While this does not mean new water is being created, it can make existing water more accessible in localized regions. However, the situation is complex. Not all parts of the Sahara are becoming greener. While some areas show increased rainfall, others remain extremely dry, or are even experiencing higher temperatures and evaporation rates. Climate models suggest that warming global temperatures could intensify weather patterns, leading to both heavier rainfall events and longer dry periods. This means the Sahara is not simply turning green in a uniform way. Instead, it is becoming more variable. Some regions may see more vegetation and seasonal water, while others continue to face desert conditions. There is also evidence that human activity plays a role in these changes. Land management, agriculture, and reforestation efforts in parts of the Sahel have helped stabilize soils and support vegetation growth. Projects like the Great Green Wall Initiative aim to restore degraded land across Africa by planting trees and improving land use practices. These efforts can enhance the natural recovery of vegetation especially when combined with increased rainfall. But scientists are careful about making long-term predictions. The African humid period developed over thousands of years due to gradual changes in Earth's orbit. The current changes observed in the Sahara are happening on much shorter timescales and are influenced by both natural climate variability and human-driven climate change. Some climate models suggest that parts of North Africa could experience increased rainfall in the future. Others predict expanding desert conditions due to rising temperatures. At this point, both trends are possible, depending on how global climate systems evolve. What is clear is that the Sahara is more dynamic than it may appear. Even the largest desert on Earth is not static. It responds to changes in climate, atmospheric circulation, and environmental conditions. In certain regions today, grasses are returning, water is briefly pooling on the surface, and ecosystems are beginning to reappear in places that were once completely barren. These changes are small compared to the vast size of the desert, but they are measurable, and they are real. The idea of a green Sahara may sound like something from the distant past, but the evidence shows that under the right conditions, the landscape can change again. For now, scientists continue to monitor rainfall patterns, vegetation growth, and underground water systems across North Africa. Because even in one of the driest places on Earth, the environment is still evolving.
Now, if you were to check out the Sahara from space right now, instead of a barren wasteland, you'd spot a surprising sight. Dry land sprinkled with some lakes and rivers in Morocco and Algeria, all thanks to some heavy rains in early September 2024. These aren't oases. This is just the Sahara going back to the factory settings. Believe it or not, eons ago, one of the biggest deserts on Earth was actually a lush paradise full of greenery. Let's first see how the Sahara turned into a desert. During the last ice age, Earth was much colder, and big ice sheets covered a lot of the land. At that time, the Sahara Desert was significantly bigger than it is today, and on our planet there were fewer tropical forests. And the cooler temperatures changed how rain was distributed in the tropics. Now, normally, warm air rises in the tropics, which helps create rain. Since it was colder during the Ice Age, this system got, messed up, and less rain fell in some areas. This caused more dry and desert-like conditions in places that are usually wetter. There was also a lot of dust blowing around in the Sahara Desert, which scientists found in old ocean sediments. But about 12,500 years ago, something surprising happened. The dust levels went way down. This meant that the Sahara got a lot wetter, which is a sign that the climate suddenly warmed up for a while before cooling down again. After 12,500 years ago, the Sahara became a much greener place, like a savanna, because a weather pattern called the Intertropical Convergence Zone, a mouthful indeed, moved north during summer. This wet period was at its best around 4,000 years ago, when temperatures were a bit warmer than today. At that time, more rain fell in the Ethiopian highlands, which made the Nile River carry more sediment. However, there was another big change called a Heinrich event, which caused the Intertropical Convergence Zone to move back south. This led to the Sahara and Arabian regions drying out quickly. Because of this, the Nile River had much less flooding between 2700 and 2100 BCE. Long story short, too late for that. The Sahara has gone through wet and dry cycles due to changes in the climate and weather patterns over thousands of years. Up until recently, we've known about the Sahara in its dry era. But in September 2024, an unusual cyclone rolled through. It hit Morocco, Algeria, Tunisia, and Libya, and filled those dry lakes and rivers. The satellite images from NASA of before and after the rains are stunning. It's like the Sahara has had a makeover. Some areas in North Africa received up to 8 inches of rain. For comparison, Seattle gets about 40 inches per year, only 5 times what the Sahara received. I say only for one simple reason. Seattle has a reputation for being quite rainy, while the Sahara does not. The tricky part is those 8 inches. Essentially, the entire yearly quota for this area fell in a matter of moments. So, in a way, it might have felt rainier in the Sahara than in Seattle. The mountains funnel the water into ephemeral lakes in northern Algeria, which recently expanded to over 70 square miles and reached depths of more than 7 feet. That's enough water to sustain it for a year. So what exactly are these ephemeral lakes? Well, they're basins that fill up for a short time each year, but might stay dry for several years if the rain doesn't cooperate. Sometimes water flows into them from a small surrounding area, or it can just be good old-fashioned rain. Now, a big question arises: how come these lakes exist in the first place? Well, generally they form because there's excess water trapped on the surface. But the soil in the Sahara is incredibly dry. Shouldn't it act like a sponge? It must be thirsting for moisture. Well, think about how eagerly your potted plant drinks up water when you return home from a vacation. However, no matter how parched it is, dry soil can only absorb a limited amount of water, which is often quite small. And just like your potted plant, it doesn't necessarily drink it all. You might simply be overwatering. Or, if you check the saucer below, you could find a mini flood. Another significant factor preventing the soil from absorbing water is the lack of vegetation. Under normal conditions, trees, shrubs, and various plants help retain moisture. In the desert, however, it's nearly impossible. There may be a few palm trees, but that's about it. This also explains the formation of those temporary lakes. Precipitation that isn't held by plants accumulates in low-lying valleys and depressions, creating these fleeting bodies of water. These lakes may only last for a limited time, but that doesn't mean they shouldn't have names. For instance, the beautiful lake adorned with swaying palms that you see is called Lake Yasmina, located in the oasis town of Merzoga. In certain areas of the desert, where the dunes rise, it may appear as though you're looking at a mirage, but it's not. The sand dunes are partially covered by water. Remember how I mentioned 8 inches? Well, that's not entirely accurate for some regions. In fact, there are places where the flooding is so extensive that the palms are submerged up to their crowns. Now, the last time we saw a downpour this intensive was 30 to 50 years ago. But this rain is more than welcome. After 6 consecutive years of drought, Morocco really needed it. Lakes that had been dry for decades, like Lake Ariki, are finally getting some much-needed water. A recent analysis revealed that out of the hundreds of storms that have hit the region since 2000, only 6 brought enough rain to start filling up this lake. And of those, only 2 resulted in a lake level higher than what we saw in September 2024. So while this torrential rain seems like a blessing, the big question is, will it last? The answer is yes. When humid air from near the equator meets the hot, dry air from the north, the Sahara Desert tends to get more rain. Scientists say this collision zone is shifting further north as the planet warms, and it warms, so it's likely to keep moving that way over the next couple of decades. So I seem a bit overly optimistic about this, and the truth is, the news isn't entirely positive. The reality is that no one was truly prepared for a flood situation like this. Moreover, remember that this isn't some Southeast Asian country where people are accustomed to dealing with water. This is the bone-dry Sahara. That said, I think you know what I'm getting at. Tragically, at least 18 people lost their lives to the intense rains in southern Morocco. The authorities are gearing up for even more heavy rain in the region. But if that's the case, could it mean the Sahara is facing extinction? And what would that even mean for us? It might sound a bit strange, but our planet actually relies on deserts, and the Sahara is no different. At first glance, it may seem like a barren wasteland, and it's nothing to write home about. But deserts play a crucial role in our ecosystem. They act as major carbon storage sites and are considered net carbon sinks, with the Sahara alone holding an estimated 1 trillion metric tons of carbon. In the fight against climate change, these existing deserts are like a buffer, helping to keep the temperatures within acceptable levels. Yeah, deserts are scorching hot, but they act as the world's air conditioning. Plus, desert sands are an unexpected source of nutrients for lush areas like tropical rainforests. Believe it or not, scientists have found that the sand particles from the Sahara have a hand in nurturing the Amazon rainforest. These particles travel across the Atlantic Ocean, riding the winds all the way to South America, where they enrich the soil in the Amazon basin. Without the Sahara, experts believe the Amazon rainforest could face serious collapse.
The Sahara Desert looks like a golden sea from above. We see endless dunes, many blue and green oases, and a huge black spot that covers an area of 17,000 square miles. Wait, what? What is it? It's a pretty gigantic territory, but why have we rarely heard of it and never seen it in movies or documentaries? Perhaps it appeared recently. Oh no, this black spot is millions of years old. Let's go down and explore the area. This place looks flat from above, but it's extremely uneven. There are black hills, slopes, and strange, tall cones everywhere. Some of them reach a height of more than 330 feet. It's higher than the Statue of Liberty, and the highest peak reaches about 3,900 feet above sea level. All these formations seem to be burnt out. This whole area resembles a giant testing ground where something big was blown up or where a large-scale fire burned. In some way, it's true. There was a fire here, not on the ground, but under it, and then it burst out. This entire territory is covered with molten lava. It came out of the ground and spread in different directions, burning everything in its path. Then, a new portion of lava came out and solidified on top of the previous layer. And so, with time, the lava formed a hill, a cone, and all the mountains located there. So, turns out this place is covered with small volcanoes? Kinda. There are about 150 of them. They're all extinct, and they're not exactly volcanoes. This place is called the Harouge Volcanic Field. But the volcanoes here don't look the way you imagine them. Here you can find different types: small vents, chimneys, and even shield volcanoes. Do you remember what shields look like in historical epic movies about ancient Greece or Sparta? These are round, flat plates with a smooth protrusion, so shield volcanoes look kinda like these inverted shields. They don't turn into a hill or a mountain because the lava coming from these volcanoes is low viscosity, more fluid, and consists mainly of basalt. It spreads further than ordinary lava and takes longer to cool. As a result of such lava eruptions, vast and massive structures appear much wider and lower than ordinary volcanoes. Some of the volcanic rocks here are up to 6 million years old. The most recent eruptions occurred only a few thousand years ago, so it's quite safe to wander around here and take photos. Probably. But why are there so many volcanoes here? Most volcanoes on the planet appear along fault lines crossing the Earth's tectonic plates. Imagine that our planet is like a jigsaw puzzle. Fault lines are the places where the puzzle pieces are attached to each other. When seismic activity occurs, red-hot magma comes out of those cracks, and at that moment, a volcano appears. Okay, so the Harouge Volcanic Field is a huge fault, right? No. The strange thing is, there's no fault line here. Moreover, it isn't even located next to any of those fault lines. Volcanoes here have a rather unusual origin. For some reason, a huge magma reservoir formed under this area, filled with a surge of molten rock, and there was so much of it that it began to bubble out from different spots. These were not explosive eruptions like those of ordinary volcanoes. Magma here poured out smoothly from numerous vents, turning the ground a dark, coal-black color. All the volcanoes here are extinct, but even if they were to awaken, it wouldn't be a sudden disaster. You'd most likely have time to escape. Okay, now let's move to the Karakum Desert, which is located in Turkmenistan. This desert covers about 70% of the country's territory. It's 135,000 square miles of sun-scorched, barren land. Even if you wander through these hot plains, valleys, and ridges for several days, you still won't leave this desert. But if you go to the north-central part of the desert, especially at night, you can see something fascinating. Already from afar, you will see a bright pillar of light, as if someone started a large-scale fire. You come closer and see a fantastic sight, a huge pit with bright flames. This place is called the Darvaza crater, and it's not a volcano. The fire has been burning here at night and during the day for weeks, months, even years. This huge pit burns 24/7 and attracts a lot of tourists. Nobody knows for sure how this crater formed, but the most popular story says geologists came here in the early 70s to drill for oil. They got to work, but the ground collapsed beneath them. 3 sinkholes appeared here and they started leaking methane. In small quantities, this gas is safe. It's used as fuel, burning in gas turbines and steam generators to produce electricity. In everyday life, this gas helps to heat houses and prepare food. But in large quantities, methane can cause health problems. It's colorless and odorless, and you may not notice that you're breathing it in. Methane is non-toxic, but it has a suffocating effect, which can lead to serious physical damage. Also, a methane leakage can harm the environment because it's a greenhouse gas. Methane emissions can lead to an increase in global temperatures and the greenhouse effect. So, let's go back to our geologist in Turkmenistan. You know, those scenes where a fire hydrant breaks in the middle of the city or a pipe bursts and the streets flood with water? Those geologists had a similar accident with methane. A huge amount of gas began to seep from under the ground, and something had to be done about it. You're in the middle of a desert next to a huge pit where dangerous explosive gas is leaking out non-stop. What would you do? Set it on fire, of course. Scientists thought the fire would soon burn all their gas reserves and everything would be fine. They set it on fire and started waiting. An hour? A day? A week? A month? Years passed, but the gas continued to burn, and it was much better for the environment than invisible seepage. This place began to attract tourists and geologists from all over the world. Many scientists wanted to look at the eternal fire to examine it, and some of them did. In 2013, a Canadian researcher came there and found out that no one really knew how that funnel had formed. Local geologists said that the crater had formed in the 60s, but people began to talk about it only in the 1980s. Now it's impossible to find exact information about the origin of the fire pit because it's classified. Why? Good question. If you have the money and desire to go to Turkmenistan to see the Darvaza crater, don't rush to do it. After lots and lots of years, the crater seems to be calming down. But why? Has all the methane run out? Nope. The authorities just stepped in and tried to stop the leak. In simple words, they found a way to turn off the valve. Now, in satellite images, you can see that the fire is almost out. On the one hand, it's sad that now you won't be able to see it with your own eyes. But on the other hand, the number of fires in this region has decreased threefold. Okay, splashes of fire and magma in the middle of hot dunes don't seem strange. What about active volcanoes in the middle of icy plains and endless snow? On the territory of West Antarctica, scientists have discovered 91 volcanoes hidden under a 2.5-mile thick layer of ice. This makes Antarctica home to the world's largest volcanic ridge. All this ice is putting a lot of pressure on volcanoes and possibly holding them from erupting. But as we know, the temperature is rising all over the world, and the ice is melting. If it loses a lot of mass, it can trigger the volcanoes, which will then melt even more ice. This will lead to higher sea levels and many other problems. But let's talk about this in another video.
So the Sahara Desert is so big that it covers 8% of the world's territory. It's bigger than the USA or China. Surprisingly, the Sahara is not the largest desert in the world. It is the third largest, behind Antarctica and the Arctic. But it is definitely the hottest one. Temperatures there reach 136 degrees Fahrenheit. This place has some of the most incredible sand dunes you've ever seen, towering up to 1,476 feet. But here's the kicker. there's a real risk that these dunes might continue to spread until they cover the entire world. Surprisingly, the influence of the Sahara Desert extends far beyond its borders. Its dust, carried by powerful winds, makes its way to the UK and across the European continent, particularly in winter. This dust settling on the ground where it rains is a familiar sight to those in the UK, often leaving a red residue on cars. This connection between the Sahara, England, and Europe serves as a stark reminder of the global reach of environmental phenomena. You might think this is not a big deal, but it could turn Europe into a desert, leaving its soil infertile and Europeans with no food. Soil is a fundamental aspect of human existence, just as crucial as clean water and air. Without it, we're left with nothing but a bleak and barren landscape. The Sahara Desert has already made its jump across the Mediterranean Sea, which is concerning and could change the landscape forever. 1/5 of Spain has already turned into a desert. The next victim is Italy, which also faces the problem of desertification. In fact, almost all European countries have the same issue. According to an expert, the land that has not changed for nearly 2,000 years will become mostly rock, and people living on this land will be gone. 60% of the soil in Moldova is gone, and the problem has expanded beyond the Black Sea. It has reached China and Mongolia, thousands of miles away from the Sahara Desert. All of this causes losses of $4 billion a year. The threat is so significant that even the UN has gathered the necessary resources to solve the problem as soon as possible. Italy is sending help to Africa to stop the Sahara Desert from expanding. If this process does not stop in the next 10 years, millions will be forced to leave their homes. The Sahara Desert is growing for approximately 30 miles per decade. You do the math and see how long it will take to cover Europe. Since 1920, the Sahara has expanded by around 10%. But not all hope is lost because more than 172 countries have joined to put a stop to the desertification of the world. The World Food Program is a project that aims to help bring back green land that was once present in the Sahara. When they told people who called the Sahara home what they were about to do, the latter basically laughed in their faces and said it was impossible. But when you have a specific goal in mind, the impossible becomes possible. If we traveled back around 5,000 years into the past, we would see a beautiful forest with lush green trees and grass. Africa's climate has been changing for 21,000 years, from fantastic greenery to uninhabitable deserts. This has to do with Earth's rotation and the monsoons that bring water to this dry continent. But with the help of scientists and some clever tricks, we can bring the greenery back and stop the Sahara in its tracks. The Senegal River serves as a border between the Sahara Desert, Senegal City, and Mauritania. When you look at this area from space, you'll see how the desert is expanding to Senegal because the vegetation along the riverbank is almost non-existent. Forests can serve as a barrier, stopping the sand from getting blown away and the desert from expanding. An effort to create a great green wall is being made, and how they do it is actually quite impressive. Nothing has been growing in the currently restored area for more than 40 years, making locals find other places to call home. People were thrilled when they saw that the land could be restored. They're very committed and learn to work with the soil and grow food. At the same moment, more than 30,000 hectares have been restored and transformed into lush greenery. The Sahel region is the starting point of desertification, and it is crucial to establish a green wall in that area first. To make this wall is not rocket science, since it only takes a few simple steps. The ground there is baked by the sun and as hard as a block of concrete. If you've ever poured water on concrete, you know that it just flows away. It doesn't stay in one place. So they had to create water-retaining half-moons that would hold the water and make it available to plants. When you learn about how these half-moons work, you might say, how did they not think of that sooner? Actually, this technique is ancient, and it was once implemented in Sahel, but it was lost over time. When the rain falls, the water is collected into the half-moons that are positioned a bit lower than the ground below contour lines. There is also a kind of bank at the end of the shape that prevents water from overflowing. And in the middle, there are plants that are happy because they have plenty of water to thrive. Also, it's essential to grow native plants that are kind of used to harsh conditions, like sorghum and millet. These plants have been surviving there for thousands of years and produce a good amount of biomass, which means the land can be rehabilitated faster and people will have food sooner. The water that will enter the half-moons won't be lost. It will penetrate the ground and top off underground waters. This will ensure the ground that H2O will never run out and that future generations will have usable aqua. This brilliant planting technique is not limited to half-moons. People also create lines and plant various vegetables, such as tomatoes. Next, there are places only for trees, like lemons or oranges. After a long hot day, nothing is better than a freshly made cold lemonade. The trees will also protect the soil, and with some luck, there will be a new forest in the Sahara Desert. The goal is to copy the forest dynamic. Start with small plants and gradually expand to bigger plants that are more useful than the tiny ones. They are aiming to plant more than 10,000 trees. Right now, many people are leaving the Sahara after the rainy season, going to cities or leaving Africa altogether. At this time of year, villages are like ghost towns. Only animals can be found there. Most people are gone. I mean, who would blame them? Nobody wants to live in the sand where nothing grows. Luckily, with all this new, old technology being developed, many people are slowly but surely returning to their land and starting to work in agriculture. The best thing is that there are no brutal winters, so plants grow 12 months a year, and people can always have food. People are becoming more social because now everybody stays in their villages and doesn't travel much. If this project works out, Africa will be saved, and the world won't turn into a giant desert. You find yourself in Africa, land of unique wildlife, home to a great variety of cultures and languages, and, first and foremost, host to the world's largest hot desert, the Sahara. It's daytime, and you are thirsty for some water and shade. You've been walking for days, trying to find one of those precious-looking oases. You feel you're near, but the horizon just keeps stretching and stretching. Your mind is tired, and your body is feeling all the heat. It's like you've eaten a full plate of hot pepper and then some more, judging by how much you're sweating. And when I say hot, think 100 degrees Fahrenheit hot, on average. No wonder this is happening. After all, you find yourself in the world's biggest hot desert. Now, I say hot desert since the biggest deserted landscapes are actually the cold ones, located in Antarctica and the Arctic. Icy Antarctica's frozen desert is more or less the size of 1 million LAXs. Yep, the Los Angeles International Airport. The Arctic Desert is just a bit smaller than that. Now, in case you don't know, the Sahara Desert is located in northern Africa, stretching from the Atlantic Ocean all the way over to the Red Sea. It occupies an area large enough to place approximately 100,000 Disney World theme parks side by side. According to scientists, its boundaries are expanding. Deserts usually form in the subtropics because of what's called Hadley circulation. The air rises at the equator and descends into the subtropics. This circulation of air has a drying effect, which helps the formation of desert landscapes. Since the 1920s, the Sahara is considered to have expanded by over 10%. How is this happening? Well, let's start from the beginning. You probably know the Sahara Desert as one of the most inhospitable places on Earth today. Just FYI, for a place to be considered a desert, it has to receive less than 4 inches of rain per year. Due to the very small precipitation index, deserts are usually dry and arid places. There is little humidity in the air, and daytime temperatures can go as high as 130 degrees Fahrenheit. Usually, there isn't that much animal and plant life because of the lack of water. But in the Sahara's case, it wasn't always like that. It may be difficult to imagine northern Africa without the tons of sand it has today. But about 20,000 years ago, the Sahara was actually one big oasis. Recent discoveries show clear evidence of what the scientists now call the Green Sahara. In the mid-1800s, a German explorer crossing the Sahara encountered some paintings and engravings that nomad artists had left behind. What he saw in those paintings looked nothing like his actual surroundings. Instead of an arid landscape with only camels and desert vegetation, the rock paintings depicted jungle animals like giraffes and hippos. There were even images of livestock and grazing animals, such as cattle and sheep, something that seems impossible for modern-day Sahara. Artists usually draw what they see around them, so this finding really intrigued the German explorer. The drawings were so detailed that the artists must have had close contact with those animals. You can find this rock art spread out in the northern part of the African continent, from western Sahara to Saudi Arabia. Geologists soon took a keen interest in this and found the first clues to what this could mean. They have been able to confirm that, in fact, northern Africa was once much wetter. They found evidence from nearby deep-sea sediment off the coast of Mauritania. Sampled cores of underwater sand and mud, known as Saharan dust flux, show geologists that, indeed, a green Sahara was possible. The more dust is blowing off of the desert and into the bottom of the ocean, the drier the climate in the region. The sediment cores show that there was much less dust, only half as much, coming off northern Africa during the humid period. This period has to do with Earth's natural cycles. Normally, the Earth rotates at a tilt of 23.5 degrees, but this angle is not consistent and changes over time. Earth's tilt is responsible for the amount of sunlight each hemisphere receives. It affects several ecosystem functions on the planet. During the time of the Green Sahara, the Earth received between 4 and 8% more sunlight than it does today. So when the Earth tilted about 20,000 years ago, the northern hemisphere received more direct sunlight, which affected humidity levels in the region. As the northern hemisphere got warmer, this affected monsoon activity, more specifically the West African monsoon. Monsoons are wind systems that affect a region's rainfall index and humidity levels. As a part of the globe gets warmer, it allows for more air to rise. It combines with the wind to draw moisture up into the atmosphere. Little by little, northern Africa also became wetter. The increased moisture made the Sahara so wet that there were actual bodies of water in the region. As vegetation grew, the plants held onto moisture better than bare sand could. There is evidence of natural basins throughout the Sahara and lakes so big they would fit all of the U.S.'s Great Lakes inside of them. Archaeologists uncovered evidence of vibrant societies in what are now arid areas. It looks like ancient cultures were able to take full advantage of the African humid period. According to researchers, the human population peaked across the Sahara about 9,000 years ago. There are traces of fireplaces, hunting tools, fishhooks, and even mounds of fish bones. Records show that there have been over 230 green periods over the span of 8 million years. Solar radiation is always changing due to natural orbital cycles. That's why Earth will most certainly see another green Sahara moment. It might be thousands of years from now, but it will happen. The same way the Sahara turns green, it turns yellow again. Let's put it like that. All it takes is a significant axial tilt and a few years of readjusting. However, another phenomenon is calling the attention of scientists now. Recent studies by the National Science Foundation from the University of Maryland show the Sahara has expanded 10% over the past 90 years. This phenomenon is called desertification, which literally means fertile land turning into desert land. The Sahara Desert is now advancing into the semi-arid region of Sahel. In 1950, this region was home to 31 million people. Today, its population is over 100 million people. This rapid population growth has largely contributed to the Sahara's expansion. Farmers that were once nomads began settling down. Land usage grew more intense, aiding in weakening the soil. The demand for food has caused an overcropping of the land, so even more of it is turning into the desert now. The study also shows that natural climate cycles can affect rainfall in the Sahara and the Sahel. Scientists affirm that all deserts fluctuate, not only the Sahara. A desert's boundary may expand in the dry winter and contract during the wetter summer. South of the Sahara lies the Chad Basin. It is a natural body of water that now serves as an indicator of the Sahara's expansion. The Chad Basin is located in the region where the Sahara is advancing southward. An atmospheric and ocean expert from the University of Maryland explains that rainfall has reduced greatly in the entire region. Due to reduced rainfalls, there is less water across the entire basin, and even Chad Lake is drying out. Just like the Sahara, the Atacama Desert in Chile, deemed the world's driest, is also expanding. It is located north of the city of Santiago, and its southern border is expanding toward the Chilean capital. Because the climate is getting drier and drier here, the city of Santiago risks turning into an arid or semi-arid region itself. The once fertile valleys of local rivers that lived on agriculture and livestock for many generations are losing their revenues as Chilean land is turning into a desert. Since 2010, Santiago has received only a third of its annual rainfall. Outside of the city, farmers are digging holes in search of blue gold, or simply put, water. The situation here is very similar to that of Sahel. So tell me this, were you as surprised as I was to find out what has been happening in the Sahara region? Feel free to share in the comments below.
Africa is ripping itself apart. A giant crack is tearing through the continent and stretching south like a zipper being pulled open. And it's happening faster than anyone expected. Now, scientists think the main trigger might not be buried deep inside Earth, but up in the sky. That's right. What might be speeding up this breakup process is the region's drying climate and brutal droughts. And that feels off, right? Usually tectonic plates move first and the climate changes afterward, but in East Africa, it might be flipped. The climate may actually be helping the plates pull apart faster. But first, let's look at what's really going on there. So, Earth's crust isn't one solid shell. It's made of giant tectonic plates, massive slabs of rock that never stop moving. They grind past each other, collide, slide under, climb over, or stretch apart. This motion is so slow, we don't notice it. But over long periods, those tiny shifts reshape continents, just like what's happening in Africa. For about 30 million years, the Arabian Plate has been moving away from the African Plate. That slow pull split the land. The seawater rushed in to fill the gap, forming the Red Sea and the Gulf of Aden. And that's not the only breakup happening there. In Eastern Africa, the Somali Plate is stretching away from the Nubian Plate. This is opening up the East African Rift Valley, cutting right through places like Ethiopia and Kenya. The region where these plates meet has a name. It's a triple junction. But in this case, they aren't crashing into each other. All three tectonic plates are diverging. When that happens, the crust gets pulled in different directions at once, like fabric being stretched from three corners. It weakens, thins out, and cracks open. They're pulling apart at different speeds too. The Arabian Plate is moving away from Africa at about an inch per year. The two African plates are separating more slowly, roughly between half an inch and 0.2 inches per year. And as they open that gap, hot material from deep inside Earth rises up and hardens, creating brand new seafloor along the split. I know, a few inches per year sounds ridiculously slow, but what makes this event so fascinating is that we're watching it happen in real time. We can actually see Africa slowly breaking apart, and it's terrifying. Back in 2005, a 35-mile long rift that opened up in the Ethiopian desert. The crack is 20 feet wide in some places, which is roughly the size of a shipping container. This is just one example of how active the region really is. From space, satellite images show valleys and rifts slowly widening over time. And down on the ground, people are posting videos of places where the Earth has already split open, leaving big cracks and gaps. Roads, houses, even schools are getting torn apart. The whole area keeps shaking from earthquakes, and the volcanoes are very active. What I mean is, even though this splitting process is super slow, we can actually see it happening. And it's unstoppable. Experts believe this crack in the East African Rift Valley will become a gateway. Waters of the Indian Ocean will eventually invade the valley and fill the growing gap. That will help pull the land apart even more, and eventually it'll create a brand new ocean. And we know that can happen because Earth has done it before. That's exactly how the Atlantic Ocean formed about 180 million years ago, when South America and Africa pulled away from each other. If the East African Rift keeps opening up, parts of Eastern Africa, Somalia, Kenya, Tanzania, Mozambique, and a big chunk of Ethiopia could one day break away from the rest of the continent. That means countries like Zambia and Uganda could actually end up with brand new stunning coastlines. But don't pack your swimsuit yet. Unfortunately, none of us will be swimming in the waters of this future sixth ocean anytime soon. Scientists estimate the full split would take about 5 to 10 million years. That's basically forever in human terms. But in Earth terms, it's surprisingly fast, almost like record speed. Now, scientists are trying to figure out why it's happening so fast. I mean, faster than it should. And here's a new intriguing possibility: a drying climate. One of the biggest clues starts right here at Lake Turkana. This lake in Kenya is about 19 miles wide and it's up to 400 feet deep in some places. But that's nothing compared to more than 5,000 years ago, when the lake level was up to 500 feet higher. Back then, the continent was going through something known as the African humid period. It was a time when Africa was wetter than it is today, and the Sahara wasn't a desert at all. It was green, wet, and full of lakes, rivers, and vegetation. But since then, the whole region has shifted into a much drier phase. So researchers took sediment samples from the bottom of Lake Turkana to figure out past water levels and how sediment washed into the lake over time. And while they were doing that, they noticed something else. Those sediment layers preserved lots of tiny faults and even the fingerprints of ancient earthquakes. Wait, wow! That means Lake Turkana might not be a simple lake. It could actually be one huge crack in the earth that eventually filled up with water. In other words, it could be a direct result of this whole rifting process. And now scientists think the same thing might be true for other deep, narrow lakes in the region, like Lake Malawi along the Tanzania-Mozambique border. So, scientists came up with a wild theory. What if these lakes are helping split Africa apart faster? Okay, maybe the theory isn't that wild. After all, water can indeed affect tectonic plates. For example, when glaciers melt and disappear, all that weight is removed, and the land underneath slowly pops back up, kind of like bread rising after you take something heavy off of it. That's called isostatic rebound, and big amounts of water can do the opposite. They press down on the crust, which can also affect things like faults and earthquakes. At Lake Turkana, something interesting shows up in the data. After the African humid period ended, the faults around the lake started moving faster, by about 0.007 inches per year. I know, that's a lot of zeros. But over thousands of years, that extra push can add up. And it could help explain why earthquakes might be more common in the region today than they were around 8,000 years ago. The study then ran computer simulations and found two likely reasons the shaking and fault movement sped up. First, there's less water pushing down on the ground. With that weight gone, the faults can slide more easily, like loosening a vise that was squeezing two pieces of wood together. Second, there's a volcano on an island on the south side of Lake Turkana. Deep underground, it has a pocket of hot, molten rock. When the lake level dropped after the African humid period, the pressure on the earth below eased up, like taking the lid off a pot. That lets the rock underneath melt a bit more. The extra melt flows into the volcano's magma chamber, swelling it up like a balloon. And that extra pressure can jolt nearby faults and trigger more movement. So yeah, drought and falling lake levels could be speeding up the splitting process. But it's not like the climate is creating the rift from scratch. It's more like the ground is already under tension, and the climate is giving it a little extra push. The real reason Africa is breaking apart might be related to something called super plume. an enormous column of scorching hot rock rising from deep inside the Earth. Think of it like a balloon underground that's slowly filling up. As it pushes upward, it puts pressure on the crust above it. Over time, that pressure weakens the crust and slowly cracks it apart. And even though none of us will be alive to see the final result of this process, it's still amazing to realize that we're watching a continent split, almost in real time. A giant crack, more than 2,000 miles long, is splitting open across Africa. Roads, houses, even schools are getting torn apart. Now, scientists think they've finally figured out what's causing it. An enormous column of scorching hot rock called superplume, rising from deep inside the Earth. And it's slowly pushing the land apart inch by inch. This isn't a small shift though. The continent is breaking in two, and the clue to what's going on could be hidden thousands of miles away in Hawaii. And why does the United States suddenly have a role in all of this? Hang on, we'll get there. First, it's important to know this isn't new information. Africa has been slowly splitting for about 25 million years. This is happening in a region called the East African Rift System. It stretches thousands of miles from Ethiopia down to Mozambique and is the largest active continental rift system on the planet. And by that, I mean places where the Earth's crust is being stretched and pulled apart, causing faults, earthquakes, and volcanic eruptions. Scary stuff to say the least. Back in 2018, for example, a massive crack appeared near a small town just west of Kenya's capital, Nairobi. In some spots, it was about 65 feet wide. That's almost the length of two school buses parked one after the other. The whole thing was terrifying. It happened fast and left a trail of destruction. Roads were cut off, farms torn apart. People were on edge as the ground opened up beneath their feet. And I mean that quite literally. One man watched the crack rip straight through his home. He barely had time to grab a few of his belongings before his entire house collapsed. Sounds terrifying, right? Since it happened in the East African Rift region, panic spread fast. The media was all over it, claiming it was proof that Africa is splitting apart. People standing near the crack thought, oh boy, it's already happening. And many still believe that today. But that's not actually the case. At least not with that particular crack. Because after the initial panic, videos and photos of it revealed clues that it wasn't related to tectonic plate movement. First clue, the two sides of the crack didn't match. Like trying to fit the wrong puzzle pieces together. They simply didn't line up. Second clue, the gap wasn't one continuous line. There was some kind of soiled bridges in between. All this showed it was sudden erosion. I mean, some specialists believe the crack had once been filled with volcanic ash from nearby Mount Longonot. But then the region was hit with heavy rains. When water soaked through the soil, it washed the ash away, leaving the gap exposed. Problem solved. Even after the truth came out, it was too late. This event brought the whole Africa is splitting talk back. And here's the thing. Even though that crack had nothing to do with it, make no mistake, Africa is breaking apart. That's because the continent sits between two tectonic plates, the Somali plate in the east and the Nubian plate in the west. The problem is they're moving away from each other, and as they drift apart, the gap in the East African Rift keeps getting wider. Eventually, the Somali plate could split completely from the Nubian plate, creating an entirely new landmass, something on the scale of Madagascar or even New Zealand. You don't have to worry though. This process is super slow. So slow that none of us will see it finished. Experts say the continent is moving apart by about 0.3 inches a year in some places. To give you an idea, that's less than the length of your fingernail. So we can say this split will take millions of years, which is good news for the people living there. But that doesn't mean they won't feel the effects of this slow break. In fact, they're already happening. Take Ethiopia's Afar region, for example. Back in 2005, this area showed just how unpredictable the rift can be. In a short period, 420 earthquakes hit the area, opening up a massive fissure. What usually takes centuries happened in just a few days. completely challenging what scientists thought they knew about the speed of geological changes. Back then, the crack stretched for more than 35 miles, and life around it is still far from easy. Recent earthquakes destroyed much of the local infrastructure. 37 schools were damaged, leaving 5,000 students without classrooms. And that was just one part of the damage. As the tectonic plates keep moving apart, water will eventually flood into this region, creating a brand new ocean, according to some predictions. Countries like Zambia and Uganda, which are landlocked today, could one day have a coastline. That could be great news for them, as it might open up new trade routes and completely reshape their economies. Don't get too excited though. We won't be diving into the waters of this sixth ocean anytime soon. The splitting process will take another 5 to 10 million years. But it's tough to say exactly when, since big seismic events, like earthquakes, could make it all happen faster. So here's what we know. The Somali Plate and the Nubian Plate are in the middle of a dramatic tectonic breakup, slowly moving apart. Africa is breaking in two. Earth will probably gain a new ocean because of it. But until recently, we didn't know exactly what was triggering all of this. Like, yeah, those tectonic plates are moving, but why? I mean, is this massive geological process being driven by something happening in Earth's mantle? Or could it have a much larger, deeper source? Well, scientists think they may have finally cracked the mystery. They believe the continent is breaking apart because there's a deep mantle superplume, a huge column of hot rock beneath the East African Rift System. Think of it as a massive subterranean hammer pushing upward, pressing against the crust, and slowly cracking it apart. But here's the interesting thing. Scientists reached that conclusion thanks to something that happened in a completely different part of the world, Hawaii. Under this US state, there's also a plume of super hot rock rising from deep inside the planet. It melts the crust above it, and that's what fuels Hawaii's volcanoes. As the Pacific Plate drifts over this plume, molten rock breaks through in new spots, creating volcano after volcano. Over millions of years, that's how the Hawaiian Islands were formed. This Hawaiian plume contains noble gases like helium and neon. And you know where else scientists found those same gases? That's right, beneath the East African Rift System. Bingo! That discovery backed up the theory that a superplume is driving what's happening in Africa. And we call it super because it might be massive. You see, these same gases have been found in volcanic rocks from Kenya all the way down to Malawi. So everything points to the existence of a single superplume that stretches from the Indian Ocean to the Red Sea, not a bunch of several isolated sources. If their data and research are correct, scientists estimate that this superplume beneath Africa likely starts at the core mantle boundary, which is located about 1,800 miles deep inside the Earth. While the East African Rift System's chemical signatures are similar to those found in volcanic rocks in Hawaii, they're not identical. The Hawaiian plume is thought to be a narrow, rising stream of hot mantle, a bit like the movement inside a lava lamp. Africa's plume might be shaped differently, more like a large mass of hot, buoyant material rising from deep within the Earth. As it reaches the surface, this hot material hits the colder, solid outer layer and spreads out, pushing hard enough to crack it open and trigger intense volcanic activity across the region. And if this theory is right, we're watching a slow but unstoppable force that will redraw Africa's map and change the continent forever.
Experts explain Africa is splitting in two, and it will look like this. Up close, the process is even more shocking, with a massive crack stretching from Mozambique in the south to the Red Sea in the north. This gap keeps growing every year, tearing apart the land and destroying homes. Now, specialists believe the continent could split much sooner than we expect. Africa is breaking apart because of the Somali Plate movement. Think of it like a dramatic breakup happening with tectonic plates. On the east side, there's the Somali Plate. On the west, we have the Nubian Plate. And during this breakup, the Somali Plate just wants more space, so it's pulling away from the Nubian Plate. This movement is forming the East African Rift, a region where tectonic plates are splitting apart, magma keeps rising from deep below, and a bunch of active volcanoes are being born. So this place is hot, with daytime temperatures that can soar to 130 degrees Fahrenheit, and at night they cool down to 95 degrees. Inside this hot zone, we have the Afar Triangle, also known as the Afar Depression, and its geology is fascinating, as the rifting process is causing valleys, faults, and deep cracks to form in this region. Take, for example, this massive 35-mile-long fissure in Ethiopia's desert. It's also so wide that a person can easily fit inside of it. But what's scary is this crack keeps getting bigger, growing about a half an inch every year. The Nubian and Somali plates moving apart could also lead to a new ocean forming in Africa. This type of process isn't something new. About 150 million years ago, when dinosaurs were still around, a similar tectonic shift created the Atlantic Ocean. The continents were once all clustered together, but when a rift formed in what was Pangaea, it started pulling them apart, splitting the east and west hemispheres. So, a similar thing is happening with this gap in Africa. At some point, experts say the waters of the Indian Ocean might flood the East African Rift Valley, eventually creating a sixth ocean. Now, it's a pity you won't be able to swim in its waters during your lifetime, though. According to geophysicist Ken McDonald, who specializes in tectonic faults, this dramatic rupture could happen in 1 to 5 million years. Trust me, that's considered fast in geologic terms, and way sooner than most experts thought. Now, even though you won't get to watch Africa breaking apart, people there will still see and feel the signs. They might experience intense volcanic eruptions and strong earthquakes as this process slowly unfolds. One example is related to that scary crack in Ethiopia's desert we mentioned earlier. The fissure was created in 2005, after the area was hit by 2 volcanic eruptions and 163 earthquakes, each with a magnitude greater than 3.9. A crack this deep and long on Earth usually takes centuries to form, but in this case, it unfolded in just a matter of days. That's how powerful this event is. In fact, this kind of intense seismic activity can speed up the African splitting process, and that's why it's so hard to predict the exact time frame for the event. What we know is that people are already calling this new land the Nubian continent. If the predictions are right, it will include Somalia, Kenya, Tanzania, and part of Ethiopia. That's exciting and concerning at the same time. As new coastlines emerge, countries will need to make major adjustments when it comes to infrastructure and land management. They might lose a lot of roads, houses, and other constructions currently located near or right in the East African Rift. In Kenya, for example, the fissures tore apart a busy road, and authorities desperately tried to fill the gap with rocks and cement. In another case, an old woman was sitting and eating with her family when her house suddenly split down the middle. Recently, earthquakes that happened near Ethiopia's Afar region demolished 37 schools and forced about 5,000 students to leave their classrooms. Unfortunately, stories like this could become more common over the next few years. But there is a positive side to all this. Countries located in the middle of Africa, like Zambia and Uganda, could gain coastlines, and that might be great for them. Having a coast means they would get access to new trade routes, opening fresh economic opportunities. Plus, think about the tourism boom. With all those newly formed paradisical beaches, these countries could become the next big gateway spot for travelers. The local ecosystem in this newly created ocean will change as well, and new marine species may emerge. So, let's look. This is the path where the rift is most advanced right now. I mean, we expect this is where Africa will eventually get separated. But things could get a little more complicated. Some time ago, Michael Daly, a geologist at the University of Oxford, suggested that this rift could extend further west. And some new evidence backs up his theory, pointing out that the crack could extend south through Botswana's heartland into South Africa and west through Namibia, all the way to the Atlantic Ocean. If these fractures widened into deep cracks, the ocean might come in and fill the gaps. Experts say Africa could split so much that it becomes an archipelago. But then again, we won't see that happening. It will take tens of millions of years for this to play out. We already know that Africa is at risk of breaking into a bunch of huge islands or small continents. The news isn't great for Madagascar either, as the world's fourth largest island could end up being split in half. But can the opposite process happen? I mean, can new land appear as the Nubian and Somali plates move apart? Well, as these tectonic plates get away from each other, the magma from the Earth's mantle might rise to the surface, and when it cools, it solidifies into new land. That's how other places in the world emerged, like Iceland and the Azores. So, yeah, the same process could happen in the East African Rift, and over the long term, it is possible that the rift could create new islands. For now, all we can say is that the geology of the Afar Depression is unique. It is the most active rift system on our planet. And when I say rift system, I mean a zone where tectonic plates are pulling apart. This region brings together all kinds of events, from faults in the Earth's crust to volcanic zones to the potential formation of a sixth ocean. For experts, it's like studying the evolution of rifts up close. And since it is such an active volcanic area, it also has enormous potential for tapping into geothermal energy, that is, using heat from inside the Earth to generate electricity. 2 geothermal power plants are already producing energy in Ethiopia, one in the Ethiopian Rift Valley and the other in the Afar. Now, geologists are exploring new potential spots. When we look at that deep crack in the ground, we know it's caused by tectonic plate movement. There's no mystery there. But what we still don't fully understand is why the cracks happen exactly where they do. For example, a crack that opened up in Botswana appeared after a magnitude 6.5 earthquake back in 2017. But the epicenter wasn't in the rift zone, where the plates are moving like we would expect. Instead, it was farther south. Since it's unusual for a rift to happen without volcanic activity, this fact really challenges our traditional ideas of how continents divide. Figuring out why these cracks appear in specific spots is still a missing piece of the puzzle for experts trying to explain how Africa is splitting. Hopefully, we get some answers before the continent turns into a massive archipelago. Wow, this port is so buzzing! Thousands of people come here every day to work, cargoes come and go, fishers are weighing their catches for the day, and even posh cruise ships pop in here to show this idyllic place to all the people on vacay. The ocean shore is fantastic. People walk along the beach eating ice cream or building sandcastles. Oh, and by the way, right now we're standing where the Sahara Desert used to be. Normally our lifetime is too short to see any major changes. We don't notice mountains rise or the way rivers change their course. Entire valleys may be sinking, but it usually takes too long for them to sink entirely. Still, a group of scientists recently noticed there's a new ocean being formed really fast, and we can even witness it appear. Look here! It's the Afar Triangle. There's the Horn of Africa Peninsula not far away. It's the exact site where the sixth ocean is being born at the moment. Wherever you are, you're basically standing or sitting on a tectonic plate. You're just sitting on a couch watching this video? Cool! Your couch is standing on the floor, your floor makes part of your house is standing on the ground, and if you take a deeper look, it all stands on one of 15 principal tectonic plates. Together, these chunks are referred to as lithosphere. It's like a nice apple pie. The crust is the lithosphere, and the fragile apple filling is everything that's on the planet's surface. If the crust cracks, the filling leaks out. And this is what any earthquake is like. A tectonic plate, aka the crust, moves. The filling, also known as houses and people, is disturbed. Africa is made up of 2 plates, the Nubian and the Somali ones. Yeah, that's a large pie. And it seems like these two plates are constantly separating. It leads to an oceanic spreading ridge. It looks like the African continent is literally unzipping a part of it at this moment. A 345 square mile chunk of the Sahara Desert just split, so the magma rose. It triggered a series of earthquakes across Ethiopia, Eritrea, and Djibouti. And it's not just some minor earthquake. There are lots of fumes rising from those fissures, and it smells like sulfur. Phew! The eruptions slowly push the old lava sediments away, which is followed by creation of the new seafloor. The crack is filled with magma, and when it cools, it forms the new oceanic floor. If this process doesn't stop, the Red Sea will finally flood the area, forming the Sixth Ocean, and Africa will be split into two parts. So we'll basically have two Africas. But wait. Neither you nor your grandchildren are going to see that Sixth Ocean. You'll only have 5 of them throughout your life. Same with our future generations. Same old Pacific, Atlantic, Indian, Arctic, and the Southern Oceans. Before the oceanic floor gets solid, and before the Red Sea actually starts flowing in there, many thousands, if not millions of years must pass. The continents move as fast as your nails grow, and imagine that the longest nail ever seen in history was the thumbnail of an Indian man reaching almost 6.5 feet before he cut his nails. It took him almost 60 years to grow it. Now think how far the continents will have to move by the time you celebrate your 100th birthday. Spoiler, it's not going to be very far. But anyway, you can witness some minor changes that take place even now. All those cracks that may not seem that significant so far make all the landscape in the Afar region look really unique. There's a couple more reasons for this uniqueness. Meet Erta Ale in Ethiopia, the volcano famous for its world's longest-lasting lava lake. It's located in the Afar Depression, also known as the Afar Triangle. By the way, depression refers to the sunken area. There's nothing sad about it. It's not the only volcano in this area. Eritrea, known as the Nabro volcano. It's never erupted, yet the lava in this area is pretty active. More volcanoes are to come because of the tectonic plate movements. They pull away from each other, and the Earth's crust gets thinner. The weaker the area is, the more volcanoes there are. Okay, the plates are separating, and it's kind of inevitable. It's just the question of time. This process is also called the Afar plume. We'll get more volcanoes, it's inevitable either. But how does it happen? Remember that apple pie? Yes, it was delicious. Well, things are actually much more complicated. The outer layer we walk on is relatively delicate and is made up of multiple broken pieces. It's like the eggshell or a lattice top on a pie. Let's take a deeper look at all the ingredients of this pie. If you cut a slice, you'll see it's made up of many parts, and there's something called the asthenosphere under the lithosphere. It's part of the Earth's mantle. Yeah, complicated. So the asthenosphere gets heated from within, and it rises, just like the dough when you put it in the oven. Remember those cracks on the surface of a freshly baked loaf of bread? Man, I'm getting hungry. Anyway, this is basically what happens to the Afar Triangle, and those cracks make this area split, creating those famous rifts and valleys that will possibly become so large and will probably get flooded so that the world's sixth ocean will appear there soon. Or not. Nobody's sure about it. Okay, but since the tectonic plates and, which is logical, all the continents are always on the move, we'll probably have more continents in the future. The answer is yes and no. If a part of Africa does split, we'll get one more continent, which is going to be even smaller than Australia. But there's one more possible way of how things will go. Chances are, in the next 250 million years, in the distant 250 million years, there will be no more transatlantic flights. And a walking trip from Japan to Chile will be possible too. Way too long, but possible. It's all happening now, and the first results will be noticeable in some 50 million years from today. I won't be around then. Australia will move towards Southeast Asia, and it's going to fit in just perfectly. And Africa will be pushed to Southern Europe. Still, these transformations will take a really long time. People and continents have something in common. Remember that continents move as fast as our hair and nails grow. just about 1.2 inches a month. Some of them move even 5 times faster though, but even this speed is too slow for 4,500 miles distance between Africa and Europe. One theory tells us the things we've already seen before. Well, you didn't see that with your own eyes, neither did any of your ancestors who came to America across the Atlantic hundreds of years ago. The fact is, all the continents were once one landmass known as the Pangaea supercontinent. Even though it formed over 300 million years ago and split about 180 million years ago, give or take, it might come back together. So kangaroos can easily migrate from Australia to the UK if they feel like it, but the latter might be accidentally crashed while all the continents merge together. The Americas would collide, Antarctica would drift to them, and it all will merge with the already collided Africa-Eurasia. In this scenario, one large ocean and one large continent will appear, namely Novo Pangaea. Another possible scenario claims the continents might merge into the uniform landmass or form a circle with a large sea inside and the super Pacific Ocean outside. This continent is referred to as Pangaea Ultima. The third theory might be already coming to life. The Pacific and the Atlantic Oceans might just cease to exist, forming the new ocean basin. Eurasia will be split to form a new ocean, and all the continents will migrate to merge into the supercontinent Orica. And the fourth and last theory claims that the Pacific and the Atlantic Oceans will remain almost unchanged, and all the continents but Antarctica will merge into one, leaving poor Antarctica even more isolated and abandoned than it is now. Nah, don't feel bad. Since all the continents keep drifting northwards even now, it's quite probable that almost all of them will meet up somewhere at the North Pole.
Something strange is happening in Egypt's desert. Giant, mysterious green circles are popping up everywhere, hundreds of them. And then you've got dozens of canals and roads connecting into something that looks like a river. But it's not exactly that. This is the ambitious New Delta project, and it has one controversial goal: to flood the desert. It's easy to see why. More than 90% of Egypt is desert, miles and miles of sand dunes and dry land under scorching heat. Almost nothing can grow there. So today there are basically only 2 areas where Egypt can grow large amounts of food: the Nile Valley and the Nile Delta. Together they cover only about 5% of the country's land, but their crops feed about 99% of Egyptians, and that's becoming a real problem because Egypt's population keeps growing. By 2050, estimates say their population will grow by about 40 million people, reaching nearly 160 million. The Nile Valley and the Nile Delta just won't be enough to handle that kind of demand. See the problem here, right? The population is growing, people need more food. But most of the country is desert, and there's not much room for new farms. So what can they do? The easy solution is the same one you use when your fridge is empty. You order in. Egypt does that too. They buy huge amounts of food from other countries. But importing food is expensive and time-consuming. So they need to create more space for farms. And they need it fast. That's where the New Delta project comes in. This is a massive agricultural plan meant to turn parts of the desert into green fields. The idea is to move water and farming west of the Nile. And if it works, it could expand Egypt's farmland by about 15%. Sounds great on paper, right? But in reality, this plan comes with a lot of controversy. Their idea is to create an artificial river right in the middle of the desert, about 70 miles long. To make it work, they're building tons of roads and canals to support it. And those strange green circles I mentioned earlier are irrigation systems. They pull water up from wells or pipelines, then slowly spin around and spray water in a big circle over the crops. Okay, so we've got this huge artificial river being built in the middle of the desert, but where is all that water coming from? Well, it comes from 3 main sources. The first, and by far the biggest, is treated wastewater. They take used water, the kind that goes down sinks and toilets in our homes, for example, and clean it up so it can be used safely again. To do that, they had to build a modern treatment plant in El Hammam, a town in Egypt's northern coast west of Alexandria. Its construction was completed in 2023, and it's absolutely massive. It's so big that it now holds the world record as the largest wastewater treatment plant in the world. It cleans an enormous amount of water every day, enough to fill about 3,000 Olympic-sized swimming pools, and most of that water goes straight to farming. The second source of water comes from the Nile. Basically, they're taking water from Egypt's most famous river, sending it through massive canals and pushing it deep into the desert, into this new man-made river. Finally, the third source is deep fossil groundwater. In other words, it's water from way under the desert. Down there is something called the Nubian Sandstone Aquifer, basically a huge underground reserve of water that's been trapped for thousands of years. And this is where the controversy starts. It's true that there's a lot of water under the Western Desert, but it's limited. Because this is fossil water, I mean, it's so old that it doesn't really get replaced. Once you pump it out, it won't refill anytime soon, not in our lifetime, and probably not even for many generations. On top of that, the deeper you drill, the saltier the water can get, and we don't want that. You see, most crops don't like salt. If the water is too salty, plants grow slower, give smaller harvests, or dry out. And when you keep watering with salty water, salt builds up in the soil. The water evaporates, but the salt stays. Over time, the land can turn hard, dry, and basically useless for farming. So pumping groundwater might help in the short term, but it raises a big question. Is this really doable in the long run? And there are other concerns too. The project was sold as a big win. Grow more food, create more jobs, and help Egyptians. It also boosts the economy because they're growing expensive fruits and vegetables that get sold abroad to places like Canada, Australia, and Japan. But that's also the problem. Many people complain that the project is mostly about growing crops to sell abroad. And sure, exports bring money into the country, in the big picture, but that doesn't necessarily mean food gets cheaper at home, or that poorer families can afford more. Because even though it has boosted exports, it hasn't done much to prevent massive food price inflation inside the country. So, Egypt's food security problem still isn't fully solved. Many Egyptians are still dealing with high prices and tight budgets. Another controversial thing is that no one knows how much this project actually costs. The press sometimes mentions $5.2 billion, but some experts put the total closer to $9.7 billion. Just the wastewater treatment part alone is said to cost more than $500 million, but it's very hard to know for sure. Journalists and researchers say there isn't much transparency, and the project's finances are tough to track. Experts also warn that farming in the desert is crazy expensive. Unlike the rich soil in the Nile Valley, the Western Desert is mostly dry sand with very few nutrients. So if you want to grow anything out there, you need tons of irrigation just to make the land workable. And powering all those irrigation systems takes a ton of energy, making farming in the desert even more expensive. Even if you already have a giant artificial river to help you out. Still, some people argue the risks and the costs are worth it, and that things are starting to change. Take wheat, for example. For years, Egypt has been the #1 wheat importer in the world, and that's not exactly a title you want to win, because it costs the country billions of dollars every year. So then the new Delta project comes along, and wheat becomes one of their main targets. Egyptian authorities say it helped them cut wheat imports by 17% in 2025. That saved them around $250 million. This was such a big achievement that the world now has a new #1 wheat importer, China. And it's not just wheat. Oranges, potatoes, grapes, agriculture is booming over there. According to estimates, food exports jumped from 5 million tons in 2020 to over 8 million tons in 2024. That's why we can say the new Delta project is already changing Egypt's agriculture. And from satellite images, you can see it's changing what the country looks like too. turning dry desert into bright green patches. It's real, and the transformation is pretty dramatic. So there's no doubt this project is both an impressive engineering achievement and a huge experiment. But researchers say it's still too early to know if it will actually solve Egypt's food problem. In the end, it all depends on water, energy costs, and who gets to make the big decisions. If the Nile, treated wastewater, and fossil groundwater can be managed in a sustainable way, the project could seriously boost farming. And if not, it could drain precious water, make the gap between rich and poor even bigger, and leave behind an expensive footprint on the desert.